Hey students, Mr. Davis here. We are going to go over today how to add radicals together, how to simplify radical expressions by adding them together. It's going to come in handy, especially down the line when we're dealing with more quadratics, we're dealing with more complicated equations and functions. So to start this out, I want you to think about what you might do if you were asked to simplify this expression. 2 times the square root of 8 plus 3 times the square root of 8. So your mind might be going to, maybe I'll multiply 2 times the square root of 8 in my calculator and get some decimal answer and add that to 3 times the square root of 8. Whatever that is, I find in my calculator. And the issue with that is that, well, you get an approximation of what the value is. It's not properly simplified because you're always going to be rounding in some way. You can't write out this decimal value to infinity. It's not possible. So what we do instead is we simplify this in a different way, using the properties of radicals we've been going over, like how to simplify them, but also remembering using some other algebraic properties that we've used throughout the years. And what I mean by that is this. To start out, before we even worry too much about the math behind it or learning the fast way, before we even figure that out, I want you to think about what it's asking you. 2 times the square root of 8. That's saying you have 2 square roots of 8, right? Whatever the square root of 8 is, times 2. You have double the value of the square root of 8. So this is in this box here that I'm putting, 2 times the square root of 8. Ask yourself, how many square roots of 8 do you have there? You have 2. Whatever that value is, you have 2 of them. So you could write square root of 8 plus the square root of 8 coming from this box. Because we would agree, if you have 1 square root of 8 and you add it to another square root of 8, you have 2 square roots of 8. I think we all agree on that. And over in this box, how many square roots of 8 do you have? Well, you have 3 square roots of 8. So you have a square root of 8, a square root of 8, and a square root of 8. Now, ask yourself, you are being told to add these 2 square roots of 8 and these 3 square roots of 8. So, if you're being told to add 2 square roots of 8 plus 3 square roots of 8, and count out how many you have. 1, 2, 3, 4, 5. That's 5 times the square root of 8. 5 square roots of 8. So this is the initial sum, right? 5 square roots of 8. We'll write it up here too. 5 times the square root of 8. 5 square roots of 8. Notice how in reality what we did was we added this 2 and this 3 to get 5, and we kept the square root of 8 constant. Now this should remind you of what we do with variables, right? In fact, it might help you think about this if you don't, if it's confusing to look at all these square root signs, thinking of them as variables instead might help you. So, for example, remember back all throughout the year, we would see something like 2x plus 3x. And you guys were really good at knowing immediately that you need to combine like terms there, right? All the time. You guys would look at 2x plus 3x and know immediately that's 5x. Because you knew we had x plus x right here for the 2x, and you knew that we had x plus x for the 3x, and you added up how many x's were there, and that was 5x. That was something you guys have done very well this year. The same applies to here, but here's the twist. Technically speaking, and you should know this from yesterday in our work simplifying radicals, 5 times the square root of 8 is not the most simple version of that value, right? Think about it. Can we simplify 5 times the square root of 8 more? Yes, we can. Because the square root of 8 can be simplified down, right? Now, it's not a perfect square, so we don't know off the top of our head the perfect decimal value, but we can simplify it down to another radical. So let's focus and hone in on the square root of 8 right now and simplify that down. Square root of 8. What are two numbers you can multiply to get 8? Well, 2 and 4 are your best options there, right? So in reality, we can rewrite the square root of 8 as the square root of 2 times 4. So this is 5 times the square root of 2 times 4. And then we know from our properties here, that can be rewritten as 5 times the square root of 2 times the square root of 4. And one of these square roots is a perfect square. 4 is a perfect square. So if instead you take the square root of 4, and that's 2, that 2 comes out, and that means 5 times 2 times the square root of 2. 5 times 2 is 10. 10 times the square root of 2 would be your final answer. This would be the most simplified version of 2 times the square root of 8 plus 3 times the square root of 8. Pause that. Pause the video, write down the work if you need to. Now let's do another one, okay? This next part is rather important. I need you to think about this question. Two times the square root of 10 plus 3 times the square root of 40. Now, my first question I want to ask you is, can you just add these up like we did in the last problem? Can you add 2 and 3? And then just keep 10 and 40 the same? The answer is no. The answer is no, because these are not like terms. This should be similar to a problem that you might have seen in math where we might have had 2x plus 3y. And I ask you, can you just add these up? And your answer is no, of course. They're not like terms. You would need to know what x and y are to add those up. But there is work we can do. Ask yourself the question, is this the simplest version of every term in this expression? And that answer is no. 3 square roots of 40 can be simplified down farther, right? So let's hone in on 3 square roots of 40 here for a second. Let's write it over here. 3 square roots of 40. So, for 3 square roots of 40, what are 2 factors you can multiply to get 40? Well, my mind immediately goes to 4 and 10. It could also go to 8 and 5. But I'm going to go 4 and 10 for simplicity's sake. So we can rewrite this as 3 times the square root of 10 times 4. And that's the same as 3 times the square root of 10 times the square root of 4. Now, hopefully you see where this is going. The square root of 4 is a perfect square, right? We can take that, that's 2. That 2 comes out. We have 2 times 3 times the square root of 10. 2 times 3 is 6, so you get 6 times the square root of 10. All right, hopefully you see what we just did. We just found that 3 square roots of 40 is equal to 6 square roots of 10. So, now, think about if there are any moves you can make to actually simplify this expression further. Because now we have 6 square roots of 10 written instead of 3 square roots of 40. So let's rewrite that problem all the way so that you can see what I'm asking. I gotta crouch now. Okay. So, 2 square roots of 10 plus 6 square roots of 10. Now, hopefully now it's clear that you can simplify this problem. right? You can, in fact, add these two terms together because they're like terms now. 2 square roots of 10 and 6 square roots of 10. So, how many square roots of 10 do you have here? 2. How many square roots of 10 do you have here? 6. And if you add them together, that means your final answer is 8 times the square root of 10. And this would be your final answer. Make sure to have this paused and write all the work down if you need to. Now, make sure that you think about any questions you have and you send them to me. Tomorrow's lesson, we're going to get into what happens when you throw variables into this mix. So, hope you're all staying safe, staying inside. Keep up all the good work you're doing.